My guest today is Michael Feathers. Michael, how are you, sir?
Good. How are you doing?
I'm doing great. I'm so excited to have you on my show. And I want to tell you why. If you'll indulge me for a second, I want to tell the
Sure.
story of how Michael Feathers influenced my life. It was years ago. I was a consultant and I was on a project, and the project was not working with cool technologies. All my friends were doing cool cutting edge stuff like Silverlight, for example. And I
Yeah.
was jealous. I was stuck writing this Windows Forms application, old
Hmm.
version of .NET, just spaghetti code, just horrible code that methods were thousands of lines long and included calls to the database and updates to the user interface. And I was it really kind of brought me down until I got your book, and I discovered there's an entire science around working with old code and trying to make it better and trying to get it into a good state, which was what my job was they had me, they actually brought me in specifically to make this code better and make it
Hmm.
more maintainable. And you kind of shined the light on that. I actually did some conference talks. I said, "Hey, here's how we,"
Hmm.
because your book was written in, it wasn't written in C sharp. It was a different language. I can't remember which one.
Well, it's a mix. I basically tried to include a bunch of different languages just to make
Okay.
it widely applicable.
So what I did, I created a talk for some Microsoft conferences and
Hmm.
did all my examples in C sharp and showed kind of took your ideas and distilled them to what I was working on. And it was really
Cool.
it was kind of an epiphany for me because
Hmm.
I realized there's something to be learned in just about everything, even in working with old ugly code.
Yeah, fair.
So I thank you for that. I've always
Yeah,
wanted to
sure,
tell you that
sure.
story and tell you how you had influenced
Yeah,
positively
I'm glad
something
it's
in my life.
helped. That's,
Yeah.
that's what I really enjoy hearing. So,
Yeah, and I think you're kind of the face of this working with legacy code because of that book. That people, when they
yeah,
think about working with legacy code, they think of you and they think of was it working effectively with legacy code? I don't have it in front of me, so
yeah, that's it.
let's start with a definition. What do you mean when you say legacy code?
It's a good question. And I actually have like a definition of legacy code within the book, but I think to start with, it's interesting to point out that every word that you find has more than one definition, right?
Yeah,
So I don't say mine's the best one or mine's the one that supersedes ones from the past.
sure. What's yours?
Typically, people say, "Hey, legacy code is code you got from somebody else." But my definition, at least at that point in time, was that it was code without tests, and this was really coming down to recognizing there's a real qualitative difference between code that has good test coverage and code that doesn't. And that difference is that essentially, if you have good test coverage, you can make changes and find out very quickly whether you've introduced a bug or not, right? Most of the time. And without those tests, you're just basically hunting in the dark, and you just kind of hope that you haven't messed anything up along the way. And it was kind of weird to go and sort of like come up with this definition. And it was actually something that came to me just like very quickly talking to a team one day. And somebody said, "Hey, you need to put that out in the world." I'm like, "Okay, yeah," because it's like there are many definitions, and I think that we can use definitions like that pragmatically to go and basically have the effect that we want to have on the world.
It sounds really simple when you put it that way. It seems like I should be able to just take this old ugly legacy code and just add some testers, and
Oh
I'm
yeah,
done
that's
with
the
my
hard part.
legacy anymore.
Yeah, yeah. If only it was that easy.
Why is it
Yeah,
hard?
well, it's kind of funny because in a way it's easier than most people think it is, right? When you go through the process of writing tests as you're writing code, you're kind of like you're in the middle of a problem and you're thinking about the problem. You can think about the tests that are going to go and give you feedback about the thing that you're working on, right? And then you think about, well, what am I going to do afterwards? I have all this code I don't understand. How do I actually get the expected values for the tests, right? Because quite often when you're testing, you basically have an idea of what's going to be the result of the thing that you're testing, right? But my approach to this has really been that essentially you just sort of like put in a dummy answer. Like you say, okay, well, if I call this particular function, I don't know what's going to get returned, right? But I'll just put a zero there, for instance, and see
Okay.
what happens. And maybe if you get an answer, it's like -1 or -2 or something like that. You say, oh, that's the answer. And you plug that in and you have a passing test. And this may sound like cheating, okay, but it's really not. And it comes down to kind of like reframing what you think of testing to be in a way, right? For tests to be very useful for us when we're refactoring and stuff like this, what they need to do is actually depict the current behavior of the system.
Right.
And you can approach this from the point of view of like, I don't understand what the system's doing, right? And then you basically go ahead and ask it questions in the form of tests. You get the answers, you put them into the tests, and then you have this coverage, which goes and gives you an understanding of what's going on. And better than that, it actually goes and breaks when something happens wrong, right? So I think people don't quite realize that it isn't this thing of doing all this mental processing to figure out what the answer is supposed to be. The code will give you the answers, okay? The hardest part with this in legacy code is breaking the dependencies well enough to be able to go and get the tests in place. Writing the tests is the
Yes.
easy part in general.
That was the challenge I faced when I had this
Yeah.
multi-thousand line code that
Yeah.
it wasn't just doing one thing was the problem. As I said, it was querying a database, taking that, doing some business logic, and then in the same method, updating the user interface. That's a lot of things
Yeah.
to test at once.
No, totally. And I guess the thing as well is to go and say, look, when you're deciding where you want to write your tests, you should be thinking very pragmatically. And it really comes down to this question: what do I want to refactor right now? Or what am I adding as behavior? Or what am I changing as behavior? And try to get some place which is close enough to that to be able to give you good feedback and write tests in that particular place. It doesn't mean that you don't go wide sometimes. Sometimes you basically have tests that cover like 4 or 5 classes because it's a useful cleave point in a way to go and actually get tests in place. But you can always zoom in as far as you want to go and start to get close to the thing you're about to change and get the feedback that you need. So,
Yeah, I did spend a lot of time on that project refactoring the code, get it into a state where I could write some tests. But can you talk about refactoring and the reasons why we might want to refactor? I mean, do we always want to refactor just because code is old
well,
and
it
doesn't
depends. I
have
mean, it
tests?
depends on your inclination. Quite often, some people like refactoring more than writing code, which is kind of interesting. And
Okay,
some days of the week, I'm like that as well, right? It's kind of
just
fun
for
to go and
fun.
sort of,
Fun is a
well,
good enough reason.
it's but it's kind of like it's this process of understanding what something does, right? And then as you understand it, going and saying, well, I could make this clearer, right? I can make this code so that I can, rather than spending 5 minutes understanding this thing, I can basically look almost instantaneously and see what it's doing, right? So, yeah, there's that personal reason that you might have for refactoring, but the thing that people really do care about is kind of like, what is the business reason? And the business reason is really because it slows us down when people can't understand what they're looking at. And,
Okay.
you hesitate before making your changes. Um, or basically you make changes and discover they were wrong, and then you have to go and have, iterations over that sort of thing as well. So there's this whole thing like, the scout rule. It's kind of like always leave the campsite better than you found it in a
Yes.
way. And
Former
so it's
Boy
like
Scout myself.
you should have refactoring as part of your process so that you're always leaving the area of code you're working in a better state than you basically saw it in the beginning. So,
Okay, yeah, just making it more maintainable is a good enough reason to refactor
yeah,
because it'll save you time and therefore money down
totally.
the discussion. But there's also risk involved in refactoring. I mean, especially if the code works today, any change
Yeah.
I might break it. How do we? Is it just the test enough to ensure that we don't break
They
something?
help a lot. I think you have to be very cautious and try to understand the code as you're going through the test writing process as well. Um, the thing about this, though, is that there's this, it's kind of like fear feeds on itself in a sense. All it takes is a couple of times in an old code base for somebody to go and attempt to refactor and make things better. And then they discover that they've introduced a bug, and then suddenly management says, oh, what were you doing? You shouldn't be doing that anymore.
Don't
And then
touch that code.
you become so cautious at that point that things actually start to get worse at an accelerating pace because you're not able to make the simplifications that make further development better and easier. So it's a real thing. You have to be very cautious in the very beginning with this. You have to basically sort of inculturate the idea that even though we may have a few errors when we're doing stuff like this, the goal is to have less errors over time. And you can only do that by going and being a bit aggressive with your refactoring the areas that you really care about. So, yeah.
Now, in your book, you spend a lot of time talking about some of the patterns, some of the common problems that you'll encounter
Yeah.
in legacy code and ways to address those problems. Can you just, I wouldn't have time to go through all of them. Can you give me a couple of really common problems and the answers to those problems?
Yeah, sure. It's interesting. In the book, what I did is most all the chapters are named after a problem, right? So that's kind of, I just thought, how are people going to want to read this, right? And I think one of my chapters is called, I have a large class and I don't know how to change it. What do I do, right? And it just has a series of different techniques you can use for going and actually breaking down larger classes. And some of them are things like sketching the internals of the class in terms of if you can get like a dependency diagram of how methods in the class depend upon other methods and how methods depend upon data in the class and stuff like this, you can quite often find places where it might be opportune for you to go and actually extract a class. And then there are techniques that you can use to go and extract classes without even having tests in place at all, right? Particularly in statically typed languages. And yes, there's a lot that's in that space. A lot of the things that I introduced are kind of like peripheral things. They're not really quite refactorings, but ways of going and getting more understanding of what you're about to work in.
Well, give me an example.
Another, yeah, sure. Okay, so okay, it's an interesting thing because we have many more refactoring tools than we ever used to in the industry. But it depends on the language, just how good they happen to be and stuff like this. But a very common problem that people have is they'll have like a method that's like 1,000, 2,000 lines and maybe 15 levels of indentation. Don't laugh. It's really true, David. Have you ever seen that?
No,
before?
I'm describing that project that was on.
Fair enough, right?
I'm having
But,
flashbacks right now.
But the interesting thing with that, though, is even though, I mean, you'll have tools that allow you to go and select some lines and extract some things and stuff. They don't allow you to do everything you might want to do in refactoring. You might want to sort of say, here's 5 lines of code. I want to move them up above these other things so I can extract it in a different way, for instance.
Right.
And I thought for a long while about that problem. And then I realized that essentially one of the things you can do is you can actually start to save state inside that method to some variables, right? Make them instance variables of the class. And then you write tests against those variables. And you can do this to go and start to find, like develop like a behavioral profile of like 5 or 6 lines of code in the center of that each method. And you have a test, and they basically tell you whether you change behavior or not. Then you do the refactoring, and you can see whether you did it correctly or not. Now, the thing about this is that when you first mention this to people, people are like, why do you want to do this? You basically go and put in variables just for testing. You're going to really make your code awful doing this kind of thing. But the real trick to this is recognizing that you don't leave them there, right? You can just basically put them in temporarily and write some disposable tests to facilitate the refactoring you need to do. And then you can delete those variables and delete the tests that were using them, because the tests were just there to support you in doing that refactoring. So it's, I think it's really just kind of like it's a real shift mentally, because quite often we think about, it's like I can't do anything to the code I wouldn't want to commit immediately, for instance, or wouldn't want to put in production. But you can do these things to code as long as you realize that you're doing this as a temporary, step towards where you want to be. And that can basically make a lot of things more easy to refactor than you ever would imagine.
That does make sense. And I'm recalling, I keep going back to the same project, but I remember there was
Yeah.
a line of code that really stuck in my mind in which it said something like button1.text equals connection.execute, and then it had a string of SQL. There was
Yeah.
literally, in the same line of code, there was literally database code and user interface code in the same line. And in that case, I did split that out and started to maybe.
Yeah.
I kept that in there. That was I don't know who thought that was a good idea, but it helped. And I think eventually I moved that some of those things into a separate method, and so the database call just returned the string to update the text value in there as well. So you mentioned tools. Are there some tools that you use or that you can recommend that will help?
Well, it's working with teams, I'll use whatever tools they have, but it's quite often the case because of that. They don't really concentrate on any particular tools. Quite often, almost every IDE that you have is going to have refactoring, menu items for various things that you need to do.
Okay.
But, beyond that, it really is a matter of going and, just sort of like introducing tests. And quite often that's a manual process. Except things are getting better with AI now, so you can actually generate.
Let's talk about AI, because the last time I
Sure.
saw you, you were giving a talk. I think you're writing a book on on generative AI right now. Does AI help with this?
It does. The thing that's weird about it is I was really kind of like fighting against it in the very beginning, because, well, it's like particularly the use of AI to go and write tests for you. I thought, it's kind of weird because the process of writing tests is about building your understanding. And if you have this tool going and generating the test for you, you don't really go through the understanding phase as you would otherwise, right? But I think the insight I had that really kind of helped me accept this a bit is to go and recognize that when you have code and you generate tests using AI, right, the test execution is going to tell you whether they actually are um, characterizing behavior that we have there, right? So if your test passes, it's kind of like you're seeing that there is behavior that it's detecting, and it's kind of holding in place for refactoring, right? And that's kind of cool. So if you can generate those tests, they are correct inherently in the sense that they characterize the behavior that's there. And so that means you can work with them and just go ahead and delete them when you don't like them anymore, right? Or take the time to go and review them and understand them well enough to go and say, hey, I want to keep this one, or I don't want to keep that one. So I think it's something we have to kind of like learn how to integrate into our practice a bit. I'm finding honestly that the hardest thing with generative AI right now in programming is chunk size, because quite often people try to generate like hundreds of tests, right? Or like hundreds of classes or something like that. And then what happens, you're stuck in that review mode. You have to go sit there for 10, 15, 20 minutes, a half an hour, understanding what was produced and feeling enough to feel confident in it, right? And that's really tough. So I think for me, quite often, when I'm using AI generatively, it's kind of like trying to go and break things down into very small pieces, the things I'm generating in most cases. Some bigger things you can generate if they aren't very critical. But it's all got to fit in your head, right?
Got
And
it.
yeah,
I think I
that's
can
what helps a lot.
paraphrase. Don't be using AI as a crutch, because as an excuse not to understand the code. Use it as a
Definitely.
tool to help you understand the code. I think that's what
Yes. And
you're
so you
saying.
can generate things, but like you said, you can actually use AI to go and understand something as well, right?
Yeah.
The hallucination problem with AI is really a big deal, right?
Mhm.
We don't know for sure whether the thing that we're producing is correct or not. And I think there's a way of looking at this as being a feature, I think, because if there's no guarantee that it's really correct, you can have it do a little bit of legwork to go generate something for you, but then you have to do the understanding piece, and that basically goes and makes sure a human's in the loop, really.
Interesting. I have not used AI for generating tests, but
Okay, yeah, it's
I
interesting
take
to
that back.
try.
I have used GitHub Copilot sometimes just to
Yeah,
create a couple of tests. But
hmm
ever since I moved into the architecture role, I'm writing less code than I used to. So
it happens. Yeah.
I, I miss it. This is a lot of great stuff. Is there anything we haven't covered that you feel is really critical to understanding?
Uh, well, with the AI stuff,
With anything, with all of what we talked about
anything.
before we wrap up.
Yeah, I think there is one thing, and I think it's really an interesting thing about this too, is that quite often people are terribly demoralized by the ugly code that they have to work with day in and day out,
I
right?
was.
May have happened to you, right? And I think the interesting thing to recognize is there's like this something called the Pareto distribution, like the 80-20 rule. You might have heard of
Okay.
this. It's kind of like it's like the last 20% of a project takes 80% of the time, for instance,
Right.
right? Or there's all these things that have like an 80-20 dynamic to them. And what that means for us in our work is that the we don't we don't basically touch all of the code at an equal level. It's kind of like with equal frequency, right? So there's some areas of your code that are going to get lots more change than other areas of your code. And if you basically adopt the practice of making things better in the areas you touch, it isn't too long before you basically encounter those again and get to reap the benefit of the changes you made to make things better. And often I'll show people this graph. It's like you can have like kind of like this, it's a ramp up that goes almost exponential like this, and it's really like a list of each of the files and the number of commits for the file sorted. And you'll see that there are some files that get 500 something commits over the project lifetime, and others that have like one or two, right? So when you know this, you can recognize that it isn't like you're working on a 3 million line code base. You're probably working on a, like 500 line code base, really, that in terms of
Wow.
what you actually have to experience, because there's a lot of stuff that gets changed over and over again. So all you have to do is take that first step of going and making those areas better, and very quickly you're going to get benefit. So I think that's the thing which can basically help with morale, I think, for
I
these
like it.
things.
Morale is important.
Yeah,
Um,
definitely.
where are you speaking next?
Where am I speaking next? I'm going down to LA later this week for like a kind of like a meetup group, and
Mhm.
gosh, I'm going to Romania again next year, which is kind of cool. I might be
I
going
love
to,
Romania.
yeah, isn't it a great place? It's kind of fun. Yeah. And I think Berlin in January. So, yeah.
Excellent. I won't be at any of those events, but I hope we cross paths in real life again.
Yeah, definitely. It'd be fun.
All right. Michael, thank you so much. This has been really
Thank you.
educational.
Excellent. Thanks so much. Human friends are very important, but technology can be your friend too. You just have to basically treat it with care like you would your real life friends.